Hello friends, welcome to UGC EPG Pathshala. I am Atika Dashdar from Department of Geography, Jamia Millia Islamia. I am presenting this module on behalf of Dr. Subhakanta Mohapatra. Today, we will have some understanding of climate change and its impact and role of human being. We have already discussed about various natural and human-induced causes of climate change in the previous modules. We have also analyzed about the evidences and impacts of climate change both at global as well as national level in the same module. It has now been established that the present climate change is human-induced. This is due to alarming rate of releasing of anthropogenic greenhouse gases. The most significant aspect about the increases in all the major greenhouse gases is that they have occurred after the Industrial Revolution in 18th century, which is not more than 400 years old. That is why this smaller historical period is named as Anthropocene, which is in the line of geological periods name era. The term was coined by ecologist Eugene F. Stormer but has been widely popularized by the atmospheric chemist Paul Crutzen. This is because of influence of human behavior on the Earth's atmosphere in recent centuries is so significant that it has been affecting the living organism on the Earth. This has been reinforced by the recently published IPCC 5th Assessment Report. In this module, we shall start our discussion by describing consensus among scientific community about climate change due to human activities as presented in the IPCC 5th Assessment Report. This is followed by discussion about greenhouse gas emission and radiative forcing highlight human contribution that led to climate change. We will also discuss about the greenhouse gas emission by different sector of economy. In the concluding section, an attempt has been made to highlight major mitigation and adaptation strategies to overcome or reduce the effect of climate change. The learning objectives are, after this module, you will be able to describe the climate change due to human activities, analyze the relationship between greenhouse gas emission and climate change, establish the linkages between radiative forcing and human-induced climate change, analyze the role of different sectors of economy in climate change, and suggest some mitigation and adaptation measures to overcome the effect of climate change. Climate change and the views of scientific community. In the beginning, people were not in the favor of accepting the idea that the climate change is happening due to human activities. It has already been mentioned in earlier module. However, after about 2 decades of scientific research conducted all over the world and compiled and produced in the form of 5 assessment reports by IPCC have been able to create a consensus among scientific community about human-induced climate change. These reports presented peer-reviewed consensus opinion among experts in scientific community concerning the causes of climate change. Further research areas were identified to study in detail to remove any uncertainties. The latest IPCC 5th Assessment Report concludes that the primary cause of climate change is human activity in 95 to 100% of the cases. The report has been concluded with 95% certainty that humans are responsible for the temperature increase during the period of 1951 to 2010. The evidence for human influence on the climate system has grown since the IPCC 4th Assessment Report. It is extremely likely that more than half of the observed increase in global average surface temperature from 1951 to 2010 was caused by the anthropogenic increase in greenhouse gas concentration and other anthropogenic forcing together. The report has also concluded that anthropogenic forcing have made a substantial contribution to surface temperature increases since the mid-20th century over every continental region except Antarctica. For better understanding of climate change due to anthropogenic activity, we need to understand the trend of greenhouse gas emission and its radiative properties. Before discussing about the trend of greenhouse gas emission and its radiative properties, let us discuss the anthropogenic sources of greenhouse gases. Sources of anthropogenic greenhouse gases. Do you know from where these greenhouse gases are emanating? Practically, these emissions are coming from almost all the sectors of our economy. Let us discuss 4 major greenhouse gases and their sources of origin due to anthropogenic activities. As mentioned in the module on climate change evidences and causes, the 4 major greenhouse gases are carbon dioxide, methane, nitrous oxide and fluorinated gases. Let us now discuss about the major sources of emission of these four principal greenhouse gases, particularly arising out of human activities. Carbon dioxide. The major sources of CO2 are mainly originated from burning coal, oil and gas, about 75%. About 20% of the total CO2 emission come from deforestation and decomposition of peatlands, crop residues and organic material in agricultural soils. A smaller amount are produced from turning oil and gas into plastic and other compounds that eventually are decomposed into CO2 again, which is about 3%, as well as from the manufacture of cement through decomposition of one of the main ingredient, limestone, that is also about 3%. Methane, also called CH4, it comes from a variety of sources. The largest sources is livestock, particularly cattle and sheep, about 25%. This is followed by leak of extraction, processing and distribution of natural gases, which is 15%. Other important sources are rice cultivation, which is of 12%. Associated gas from coal production is 10% and decomposition of organic waste in wastewater treatment is 9% and landfill is 7%. Nitrous oxide or N2O mainly comes from fertilized grassland and cropland, where nitrogen fertilizers are decomposed in the soil, about 35%. This is followed by animal waste, which is 26%. Surface water polluted with nitrogen account for about 15%. A small amount comes from chemical factories such as those for nylon production of 5% and wastewater treatment for 2%. A small quantity of N2O, which is about 1% of the total, come from car and catalytic converters. Fluorinated gases, which is mostly called HFCs. These gases are mainly emitted from air conditioner in car and refrigerator, as well as from the production of industrial chemical. SF6 is mainly used as the insulator in electrical equipment. Let us discuss in brief about global warming potential. Do you know what is the global warming potential of anthropogenic greenhouse gas and how do we calculate it? Global warming potential was developed for comparing the global warming impact of different gases. In other words, it is a measure to calculate how much energy the emission of 1 ton of a gas will absorb over a given period of time, relative to the emission of 1 ton of carbon dioxide. Therefore, calculation of global warming potential take into account both the radiative property of a particular greenhouse gas molecule and its lifetime existence in the atmosphere once emitted. The larger the GWP value, the more is the warming capacity of that particular given gas in comparison to CO2 over that particular time period. The time period usually used for GWPs is 100 years. This is the atmospheric lifetime of CO2. GWP of CO2 is 1 because it is the gas being used as the reference. On the other hand, methane is considerably more short-lived in the atmosphere than CO2, persisting for decades rather than centuries. This measurement is helpful for the formulation of mitigation policies. If we need to avoid a dangerous short-term climate tipping point, we might focus more effort on reducing methane because it is a particular potent, if short-lived, greenhouse gas. On the other hand, if our goal is to stabilize long-term greenhouse gas concentration, we would be better served by focusing purely on CO2 emission. To have a better understanding about the global warming and climate change due to greenhouse gas emission by anthropogenic activities, we have to understand the process of radiative forces. You have already read in other module on climatology about heat budget. Theoretically, we can say that Earth's energy balance is zero. What does this mean? This means that the amount of energy arriving at Earth's surface is equal to the amount of energy eventually radiated back to space. However, Earth's climate has cycled through period where this balance is not achieved and Earth systems are either gaining or losing heat. The term radiative forcing is also known as climate forcing. In other words, any change in the radiative balance caused by changes in the atmospheric composition. Therefore, it describes the amount by which some perturbation causes Earth's energy balance to deviate from zero. A positive forcing indicates a warming condition, whereas a negative forcing indicates cooling. Scientists at National Oceanic and Atmospheric Administration have measured the radiative forcing caused by major long-lived greenhouse gases for the period of 1979 to 2015. This is the quantified in watts of energy affecting Earth's energy budget. According to the figure, the annual greenhouse gas index value reached 1.32 in 2012. Do you know what does this indicator convey? This indicator converts the total radiative forcing for each gas into an index by using the ratio of the radiative forcing for a particular year compared with the radiative forcing in 1990. The graph shows that the radiative forcing has increased steadily for all gases, with the proportion attributed to CO2 increasing the most. According to the report given by Working Group 1 of the 5th Assessment Report of the IPCC, which deals with the physical science basis, show that there is a difference in the scientific understanding of different radiative forcing effects. It has been observed that emission can result either in an increase or a decrease in radiative forcing or RF at the global scale. Over the past 260 years, emission of CO2, CH4, N2O, F gases, black carbon, CO and NMVOC all resulted in an increase in radiative forcing. On the other hand, emission of SO2, organic carbon and mineral dust all contributed to the decrease in radiative forcing. Emission of halocarbon had both a positive and negative impact on radiative forcing. Also, the emission of NOx and NH3 have had both a positive and negative radiative forcing effect, but with a negative net impact of radiative forcing. This figure further highlights the interaction between aerosols and the clouds resulted in a negative radiative forcing, but the contribution of individual emitted compound within mixes of aerosol is unknown. Anthropogenic greenhouse gas and emission and climate change. As mentioned in the previous module as well as in the initial section of this module, that the increasing concentration in atmospheric carbon dioxide and other greenhouse gases due to anthropogenic activity is the major cause for global climate change has now been established. According to an analysis undertaken by Mann and Kump has revealed that out of all the major greenhouse gases, percentage share of CO2 emission is highest. Therefore, it plays a significant role in human-induced climate change. If we analyze contribution of major greenhouse gas, it has been observed that carbon dioxide accounted for more than 3/4 of the emission, which is about 77%. The other greenhouse gases which plays a significant role are methane, which is about 14%, nitrous oxide about 8% and the chlorofluorocarbons constitute the remaining 1%. The same has been reported by IPCC 4th Assessment Report. According to IPCC 5th Assessment Report titled Climatic Change, according to IPCC 5th Assessment Report titled Climate Change 2014 Synthesis Report, cumulative anthropogenic carbon dioxide emission to the atmosphere between 1750 and 2011 were 2050 plus minus 310 gigaton carbon dioxide. Out of the total cumulative anthropogenic carbon dioxide emission, about 40% have remained in the atmosphere, which is plus minus 880-35 gigaton of carbon dioxide. The remaining was removed from the atmosphere and stored in plant and in soil on the land and in the ocean. These vegetation and soil on land and in ocean are major sources of carbon sinks. If we analyze carbon dioxide emission over the time period, it has been observed that about half of the anthropogenic carbon dioxide emission between 1750 and 2011 have occurred in the last 40 years. The trend analysis has also revealed that total anthropogenic greenhouse gas emission have continued to increase over 1970 to 2010 with larger absolute increase between 2000 and 2010. This has happened despite of a growing number of climate change mitigation policies implemented across the world. Anthropogenic greenhouse gas emission in 2010 have reached 49 plus minus 4.5 gigatons carbon dioxide per year. Emission of carbon dioxide from fossil fuel combustion and industrial processes contributed about 78% of the total greenhouse gas emission increase from 1970 to 2010. With a similar percentage contribution for the increase during the period 2000 to 2010. As mentioned earlier, at global level, economic and population growth continued to be the most important driver of increase in carbon dioxide emission from fossil fuel combustion. The contribution of population growth between 2000 and 2010 remained roughly identical to the previous 3 decades, while the contribution of economic growth has risen sharply. Increased use of coal has reversed the long-standing trend of gradual decarbonization of the world's energy supply. Do you know what decarbonization is? Decarbonization refers to reducing the carbon intensity of energy. Therefore, major strategies of reducing the greenhouse gas emission are to control the release of greenhouse gases from fossil fuel combustion, land use change and the burning of vegetation. If we succeed in doing so, then this would lead to decrease in the projected rate and magnitude of warming. In other words, future climate change would be determined by historic, current and future emission of these greenhouse gases. Impact of human activities on climate change. Analysis of economic sectors. Analysis of the main sources of greenhouse gas emission according to the sector of the economy reveal that energy supply is the largest, which is 26% contributor of greenhouse gas, followed by industry, which is 19%, the forest sector, which is 17%, agriculture account for 14%, transport 13% and the building sector is about 8%, followed by the waste management which account for 3%. Confusion can arise around sector contribution because emission can be counted in different ways. The number given above are based on emission at the point where they enter the atmosphere, so called point of emission allocation. So, emission from electricity generation are counted under the energy supply sector. However, it can be more useful to count such emission under the sector where that electricity is used, so called end use allocation. That can give a better picture of how electricity emission is useful to know what the historical contribution to our emission have been from the various sectors. Looking forward toward the future, it is also important to know which sectors are growing most rapidly in their contribution to anthropogenic greenhouse gas emission. By comparing emission rate during the middle of the past decade with those at the beginning of 1990s, it has been observed that the largest absolute increase of nearly 3 gigaton per year of carbon dioxide released has been in the energy sector. Other sectors such as transport and forestry have shown similar 30 to 40% increase in emission over this time frame. It is logical to conclude that these sectors might demand special attention in considering possible emission mitigation approaches. According to the latest IPCC 5th Assessment Report 2014, the total annual anthropogenic greenhouse gas emission have increased by about 10 gigaton carbon dioxide per year between 2000 and 2010. This increase directly came from the energy, which account for 47%, industry account for 30%, transport account for 11% and building account for 3% sectors. Accounting for indirect emission raises the contribution by the building and industry sector. Since 2000, greenhouse gas emission have been growing in all sectors except in agriculture, forestry and other land use. In 2010, 35% of greenhouse gas emission were released by the energy sector, 24% from AFOLU, 21% by industry, 14% by transport and 6.4% by the building sector. When emission from electricity and heat production are attributed to the sector that use the final energy, which is indirect emission, the share of the industry and building sector in global greenhouse gas emission are increased to 31% and 19% respectively. Globally, economic and population growth continue to be the most important driver of increase in carbon dioxide emission from fossil fuel combustion. According to the Working Group 3rd report on summary for policymaker revealed that the contribution of population growth between 2000 and 2010 remained roughly identical to that of the previous 3 decades. While the contribution of economic growth has risen sharply, the report has also revealed that between 2000 and 2010, both drivers outpaced emission reduction from improvement in energy intensity of gross domestic product. This has happened This has happened due to increased use of coal relative to other energy sources. This has reversed the long-standing trend in gradual decarbonization of energy of the world's energy supply. Now we will discuss about the remedial measure to overcome the effects of climate change. In climate change discourse, there are two approaches to address human-induced climatic change. These are mitigation and adaptation. Mitigation has a long history in the climate policy, whereas the adaptation has recently gained importance. The concept of mitigation and adaptation. The concept mitigation in general means the reduction of the atmospheric greenhouse gases, and hence we can avoid the likelihood of the occurrence of the climatic variability and extreme events. IPCC defined mitigation as an anthropogenic intervention to reduce the sources or enhance the sinks of greenhouse gases. On the other hand, the notion adaptation is generally referred to the individual, community and societies to adjust their activities, life courses and location to take an opportunity to get advantage from the fluxes of the social ecological system. The climate change literature views it as the adjustment in human and natural system to actual or expected climatic stimuli, which can reduce the negative impact and take advantage of the positive. The need for mitigation and adaptation. As mentioned above, climate change has severe non-linear impact on the well-being of the human society. Many developing nations have already experienced weather-related extreme events in terms of floods, droughts, heat waves and tropical cyclones that are more frequent or intense than previous experiences. In general, it affects different sectors such as freshwater resources and their management, food and fiber and forest product, coastal system and low-lying areas and health etc. The resulting impact will have significant consequences on the environment, production system and livelihood from future climate variability and change. Importantly, the developing nations are facing more burden as compared to the developed nations. Meanwhile, Stern has estimated if we don't act, the overall damage cost will be equivalent to at least 5% of the GDP now and forever, and if a wider range of risk and impact is taken into account, the estimate of damage could rise to 20% of the GDP or more. Mitigation and adaptation measure by Assessment Report 5 for policymaker. IPCC 5th Assessment Report has given the following major suggestions related to mitigation and adaptation. There are two broad suggestions related to mitigation and adaptation. Under these two broad suggestions, there are 5 important specific suggestions. Let us discuss broad suggestions as well as the specific suggestions given under broad suggestions. Future pathways for adaptation, mitigation and sustainable development. Adaptation and mitigation are complementary strategies for reducing and managing the risk of climate change. Substantial emission reduction over the next few decades can reduce climate risk in the 21st century and beyond. Increased prospect for effective adaptation reduce the cost and challenges of mitigation in the longer term and contribute to climate resilient pathways for sustainable development. Climate change risk reduction by mitigation and adaptation. Without additional mitigation efforts beyond those in place today, and even with adaptation, warming by the end of the 21st century will lead to very high risk of severe, widespread and irreversible impact globally. Mitigation involves some level of co-benefit and of risk due to adverse side effects, but these risks do not involve the same possibility of severe, widespread and irreversible impact as risk from climate change, increasing the benefit from near-term mitigation effort. Characteristics of adaptation pathways. Adaptation can reduce the risk of climate change impacts, but there are limits to its effectiveness, especially with greater magnitude and rate of climate change. Taking a longer term perspective in the context of sustainable development increases the likelihood that more immediate adaptation action will also enhance future option and preparedness. Characteristics of mitigation pathways. There are multiple mitigation pathways that are likely to limit warming to below 2 degrees Celsius relative to pre-industrial levels. These pathways would require substantial emission reduction over the next few decades and near zero emission of carbon dioxide and other long-lived greenhouse gases by the end of the century. Implementing such reduction poses substantial technological, economic, social and institutional challenges which increase with delays in additional mitigation and if key technologies are not available. Limiting warming to lower or higher level involves similar challenges but on different time scales. Adaptation and mitigation. Many adaptation and mitigation options can help address climate change, but no single option is sufficient by itself. Effective implementation depends on policy and cooperation at all scales and can be enhanced through integrated response that link adaptation and mitigation with other societal objectives. Common enabling factor and constraint for adaptation and mitigation responses. Adaptation and mitigation responses are underpinned by common enabling factors. These include effective institutions and governance, innovations and investment in environmentally sound technologies and infrastructure, sustainable livelihood and behavioral and lifestyle choices. Response option for adaptation. Adaptation options exist in all sectors, but their context for implementation and potential to reduce climate-related risk differ across sectors and regions. Some adaptation response involves significant co-benefit synergies and trade-offs. Increasing climate change will increase challenges for many adaptation options. Response options for mitigation. Mitigation options are available in every major sector. Mitigation can be more cost effective if using an integrated approach that combines measures to reduce energy use and the greenhouse gas intensity of end use sectors, decarbonize energy supply, reduce net emission and enhance carbon sinks in land-based sectors. Policy approaches for adaptation and mitigation, technology and finance. Effective adaptation and mitigation responses will depend on policies and measures across multiple scales: international, regional, national and subnational. Policies across all scales supporting technology development, diffusion and transfer as well as finance for responses to climate change can complement and enhance the effectiveness of policies that directly promote adaptation and mitigation. Trade-offs, synergies and interaction with sustainable development. Climate change is the threat to sustainable development. Nonetheless, there are many opportunities to link mitigation, adaptation and the pursuit of other societal objectives through integrated response. Successful implementation relies on relevant tools, suitable governance structure and enhanced capacity to respond. Let us summarize this module. Assessment report conclude that the primary causes of climate change is human activity in 95 to 100% of the cases. The report has also concluded with 95% certainty that humans are responsible for the temperature increase during the period of 1951 to 2010. Between 1990 and 1999, an estimated 6.3 gigaton carbon dioxide per year was released due to the combustion of fossil fuel, and another 1.6 gigaton carbon dioxide per year was released due to the burning of forest vegetation. This was offset by the absorption of 2.3 gigaton carbon dioxide per year each by growing vegetation and the oceans. This left a balance of 3.3 gigaton carbon dioxide per year in the atmosphere. Controlling the release of greenhouse gas from fossil fuel combustion, land use change and the burning of vegetation are therefore obvious opportunities for reducing greenhouse gas emission and can decrease the projected rate and magnitude of warming. The term radiative forcing describes the amount by which some perturbation causes Earth's energy balance to deviate from zero. A positive forcing indicates a warming condition, whereas a negative forcing indicates cooling. If we organize the main sources of greenhouse gas emission according to the sector of the economy, we see that energy supply is largest, which is about 26% contributor of greenhouse gas, followed by industry which is 19%, the forest sector 17%, agriculture 14%, transport 13% and building sector is about 8%, followed by waste management which is 3%. Remedial measures to overcome or reduce the effect of climate change can be addressed by undertaking both adaptation and mitigation measures. According to IPCC, mitigation refers to an anthropogenic intervention to reduce the sources or enhance the sink of greenhouse gases. According to UNFCCC, adaptation refers to the adjustment in human and natural system to actual or expected climatic stimuli, which can reduce the negative impact and take advantage of the positive. IPCC 5th assessment report has given the following major suggestion related to mitigation and adaptation. There are two broad suggestions related to mitigation under adaptation. Under these two broad suggestions, there are 5 important specific suggestions. Thank you and hope you have a nice time.